This is a presentation on the Metron block. On the left here you see a picture of the Metron block. This is a hoof block used to place the horse's hoof on when we take radiographs and or photographs. And on the right you see some things going by showing you what we can do with the block, what it enables it to be done with the Metron software, and it can be used with other software as well. It's a general use good equine hoof block. In fact, if you pay attention to this presentation, I think you'll agree by the end that there is no other hoof block like it with all the features that it has. So let's just get into that. If you want to measure things in images, and the horse's hoof in this case, you start with taking good images, and secondly, you should have a scale marker in the image so you can calibrate things and get accurate measurements. Unfortunately, today's typical practice when it comes to the horse's foot and radiography and photography, we have images like this. These are taken on a block with no scale markers in it. They're taken sometimes from strange angles, no attempt to get a good image that could actually be reliably measured. In contrast, we want to end up with beautiful images like this, true laterals taken side on, both radiographs and photographs, in which we can measure things, and the linear measurements that we make are accurate because there's a scale marker used in the system. So that's what we're after. You have to be careful with a lot of today's DR systems. You might see a display like this where it displays sort of these tick marks or a ruler on the side of the screen. That can give you the false impression that you can make accurate measurements in that system, but you probably can't. Unless you typed in a bunch of information about standoff distances and things, which you probably didn't, there's no way the DR system can know what the effective magnification is, and so these things are approximate at best. And some manufacturers have gone so far to admit it and put a big warning on their images saying sizes are approximate, like you see here. So it's sort of a shame that the current state-of-the-art veterinarians pay a lot of money for x-ray systems, and they can't even make accurate measurements because the vendors don't even try to help them with that task. The other hoof blocks in the market, many of these are very fancy and shiny and expensive, and some come from Europe. None of these have a scale marker in it. It's like the manufacturer couldn't be bothered to place two BBs a certain distance apart, which is all you really need to get started. But none of these systems have scale markers built in. The Metron block has been on the market for 10 years or so, and has gradually added some features to it, which we'll go over in this presentation. And again, this block is a general good block for taking x-rays, laterals, and DPs, also for taking laterals and DPs photos of the hoof. So here's an example image taken in A. In B, the Metron software has located the scale marker within the block, and in C, that enables accurate linear measurements to be made. The geometry of radiography is such that the X-ray generator emits X-rays coming from a point source, essentially, and they are diverging as they go out. So in the setup, as you see in this cartoon, a bone of a certain size, by the time it's imaged on the X-ray detector, it looks much bigger than it really was. That is inherent magnification, which is true in any X-ray image. And how much it's magnified depends on how far away the generator is from the thing you're imaging and how far away the detector is. These physical standoff distances, which no software system can know unless you spend some time putting it in. But a way around having to know those things is to use a scale marker, as we'll see. And that's why a block is needed for properly imaging the horse's hoof, because the beam is diverging as we see here, and to fully image the bottom periphery of the hoof, the beam ends up going lower than the surface the hoof is standing on by the time it hits the plate. And so you absolutely must put the hoof on a block if you want to take a proper x-ray of a horse's foot. And as long as you're using a block, it's very convenient to have a metal scale marker inside that block. So you've used the block as you need to, and you've accomplished the scaling problem. So here's the Metron block, and the proper use of it is to stand the horse with the center line of the hoof capsule on the center line of the block, and typically we try and put the widest part of the foot on the fiducial lines going out the width of the block. So this is where the hoof would be standing on the block. You do not put the hoof over next to the imaging plate. You put it in the center of the block, and then everything is scaled properly. So, hoof radiography done right, you use a hoof block that has an integrated scale marker. That makes a lot of sense. You stand the horse properly on the block, and really you want to have both front feet on the block. I mean, ideally you'd have all 4 feet on blocks of equal height. That's usually prohibitively difficult to get the horse to do, so typically we just do 2 feet at a time on blocks. And then ideally the DR system would automatically recognize the scale marker and apply the calibration, so there's nothing to worry about or nothing to do. That may or may not be possible with the software you have, but at least you'll have a scale marker in it if you use the Metron block. We also say for measuring, for the purpose of measuring, it's better to place the generator further away from the thing you're trying to measure. So a lot of generators are set up to be 26 inches away from the detector. Better to put it at 36 or even 40. They set the technique a bit higher, column 8 down, the patient gets the same dose, but you have a much better image for measuring. So let's take a look at an example of this working. Here is a cadaver leg split in 2, and where the red arrows indicate, we've placed little tiny BBs, one at the tip of the P3 bone and one at the approximate center of articulation of the coffin joint. And then with a physical ruler, we just hold the ruler up to it, we can measure that those things are 3 1/8 inch apart, or 3.125 inches. Okay. Now we put that on a block and we take an X-ray. In our system, the scale marker in the block, which you see at the bottom of the image, is used, and the distance computed between those 2 BBs is exactly 3.12 inches. So that's perfect. That's an accurate measurement. Those BBs are right on the center line of the block. All of our measurements are resolved to the center line of the block, and that's why you place the hoof centered on the center line of the block. Now, an interesting thing is, in this case, we put the foot on the right-hand image on top of 2 blocks, so it's up higher. We didn't change the generator. The red crosses show you the central beam of where the generator was for each image, and you see that we still get an exactly accurate measurement for that distance. And this is helping to point out that anything in the plane of the center line of the block, anywhere in that plane, doesn't have to be near the beam center. Anywhere in that plane, you'll have accurate measurements. And here we did 4 different physical setups where we move the generator closer, move the panel further away. All the details are shown here. We don't have to go through them, but we've shown the film focal distance and what I call the object film distance in yellow on each image, and the amount of magnification that that implies. You'll see, for example, the lower right-hand image looks physically bigger because there's almost 70% of magnification just by the physical setup. But you see that the measurement made, the critical measurement between those 2 points, is exactly the same in all images. So if you use the Metron block, you do not have to worry about how far you put the generator down. You don't have to worry about where the panel was relative to the foot. Everything is taken care of by having a scale marker in the center line of the block. Let's talk for a minute about photographing the hoof. It's done less often, but can be interesting. We've invented this thing called the Eponocam, which is a smartphone cradle. You put your phone in it. The lens of the camera in the phone bounces off a mirror at 45 degrees and shoots across exactly at the height of the block, so you get beautiful edge-on images. We've got other presentations about this, so we won't really go into it much here. But let's look at a photo. Here there's a ruler placed on the center line of the block, and the blue line, which you can see on the ruler is clearly 5 inches long, is measuring in the software at only being 4.33 inches because we used a scale marker that's on the outer edge of the block, the green line on the outer edge of the block. And that's what a lot of practitioners do. They'll put a little ruler or some fiducial marks on the side of a block, but you're getting errors by the time you get back to the center line of the block, right? So that's not really a good solution. The Metron block uses 4 fiducial points, 2 on the outer edge of the block and 2 in these wells that you can see. And by picking those 4 points, we can actually compute a perfect calibration at the center line of the block. And now you see that the blue line on the ruler is measured to be 5 inches long, and it is 5 inches long, so we have perfect calibration. And again, it doesn't matter how close or far away the camera is from the block, it'll all be taken care of for you, and you'll get accurate measurements right up the center line of the hoof if you've centered the hoof on the block. And this can be important. Here's two images. It's the exact same image, but one is using our 4-point scheme, and one is using a scale marker on the outer edge of the block, as many practitioners do. And here you see you're off by 0.2 of an inch, and if you're telling a farrier how much to trim off the heel, that could be very important. So this actually does matter, this stuff. Another thing to say is it is good, just like I said before, the generator in an X-ray being further from the hoof makes a better image. So it is with the camera. The further it is from the hoof, the better image you get. So on the left, we are about 30 centimeters from the hoof. On the right, we're about 2 meters from the hoof. It's the same exact hoof on the same date. It's just taken 13 seconds apart. But look how different the hooves look. Look at the hairline on the left. Seems to go way up compared to the image on the right. So the answer is you want to keep the camera at least a meter away from the hoof, and even further than a meter is okay. Again, you get better measurements, better images for making measurements. And here's some measures. You see how they've changed quite a bit. Now, interestingly, measurements on the center line of the hoof in these two situations would come out exactly the same as we saw before. But as you come off the center line of the hoof, you have like a less of a depth of field of good measurements, if you can follow that. The further you get away with the camera, you'll have a flatter image, not bug eye, and you'll have a greater depth of accurate measurements about the center line of the block. For solar photos of the hoof, we use a separate scale marker that you put on your finger, and you hold that so it's in the plane of the hoof, and take a photo like this, and then you get accurate measurements, look for contracted heels and so forth. We won't talk much about this view. So, take-home message for photographing the hoof. A hoof block with integrated scale marker makes a lot of sense. Stand the horse on the block properly, ideally all 4 feet, but usually just 2 feet. It's really a nice idea to put a blank background board behind the hoof so you don't see the opposite leg and you don't see the background clutter. And then the camera has to be held low. Most practitioners hold it too high. The center of the lens of the camera should be at the same height as the block, which means for most cameras, the camera is essentially on the floor. And you get a better image for measuring if you go back about a meter away. Don't get too close. And then zoom in. A possible alternative to a scale marker built into the block is to have a separate scale marker like this that you set at the toe of the hoof on a dumb block. And we have this thing, we call it the autoscaler. It's got an external scale for photography and an internal metallization for radiography. But we find it's one more thing to handle around the horse, and I think it's just easier to have the scale marker built into the block, and then you're done with it. So people sometimes ask how accurate are the measurements made in our overall software system based on the Metron block. I'll just point out that there's been a couple of independent papers written by university folks that we had no contact with that seem to back us up that everything works pretty well and it's accurate. Now I wanted to show a couple things that come up in conversation. Some people say, yeah, but if you don't properly place the hoof on the block, then everything's going to be garbage. But this demonstration is a sequence of radiographs put together to make like an animation. And you see in the cartoon in the upper left-hand corner, we're rotating the block and the hoof on it relative to the X-ray setup. We're actually rotating it by plus or minus 15 degrees, and then we're computing the palmar angle in each image. And the results are over on the right. If you align the foot within plus or minus 10 degrees, which is still a large deviation, you'll get a palmar angle measurement within about 2/3 of a degree. And really the unaided human eye can probably orient a foot on a block within 5 degrees. So things degrade if you're not perfectly perpendicular, but it's not crazy. It's still pretty well conditioned as long as you're within 5 or 10 degrees of the perfect shot. And another thing that is discussed is how high the block should be relative to the generator central beam. And some schools teach to point the beam at the navicular bone. Other people think shoot the beam right across the top of the block. So this demonstration, we were raising the height of the generator beam. The red cross shows you where the generator beam is located. And as we move up and down, we took a series of x-rays and computed the palmar angle. Let me go back to that. And you'll see the palmar angle is not changing a great deal. So again, at least for the palmar angle, it's fairly robust to where you're pointing the x-ray beam. You don't have to really concern yourself too much about the exact height of the block, the exact height of your generator. Things are pretty good, pretty robust. Again, in this example, I did have the generator 36 inches away, and that helps. If you're in closer, like at 26 inches, you'll see more of a variation. So there's a bunch of reasons why being a little bit further from the hoof, both for radiography and photography, gets you better images. And then another thing that can affect the palmar angle is the horses stand and they shift their weight back and forth. So we've heard people say, oh, that destroys the measurement. Here you see a very, I would say, radical shift where on the right-hand image the horse is fully weight-bearing on one hoof, and on the left he's standing normally. And you see a big angulation change, but if you look at the palmar angle, it's only changed by 0.2 degrees, plus or minus 0.2 degrees. So if you add up the horse shifting and not being quite aligned and everything that we've just looked at, I think you can get a good palmar angle within a degree, and probably within half a degree, actually. So it is possible to make good measurements in horses' feet, in case you didn't know that. There's one final feature with the block that came recently that I want to point to. It's a little bit fancy, but it's interesting. Here are two images. It's actually the same image that's been mirrored. So the original image is on the left. That's a right foot. It's a right foot taken from the lateral side, so the toe is pointing to the right. If you mirror that or laterally flip the image, which is available in most any software package, then you get the image on the right. And the problem can be that you might not, if the image is not labeled, you might not know, is this a right foot or is this a left foot? So here's an example of a radiograph and a photograph. And again, you might wonder which foot this is. It looks like a right foot because the toe is pointing to the right and we're on the lateral side of the horse. But maybe it's an image that's been mirrored by some other software before it was sent to you. So maybe it's really a left foot that's been mirrored. And of course you don't want to do a procedure on the wrong foot of a horse or anything like that. So it can be important to keep track of which foot is which. So the latest generation Metron block, if you look here in this image, on the side of the block, there's a red dot now on the latest incarnation. And that tells you it's the latest block. And here's how it works. For photographs, the images on the top have not been mirrored. And the red dot on the block is always on the left-hand side of the image, left-hand side of the block. The images in the bottom are those same images that have been mirrored, and now we see the red dot is on the right-hand side. So it's very simple. If you see the red dot on the right-hand side of the block, that means that image was mirrored, and you have to flip the laterality of the foot from how it looks. In radiography, there's a new piece of metal added to the block, and you see down the lower left-hand corner in a pink square, I've highlighted this piece of metal. That's just like what we just saw for photography. That should be on the left-hand side if the image hasn't been mirrored. The image on the right, it appears on the right-hand side, and so that means it has been mirrored. So that's how it works for DPs. For laterals, it's a little bit more complicated, and we won't go into all the details, but that same piece of metal can be seen here in the lower left of both of these images. And we essentially measure the length of that, the apparent length of that metal, and it will appear longer or shorter based on magnification, because in one case it was next to the DR panel, in the other case it was farther away from it. So by looking at that, we can determine the image on the right is a right foot. The image on the left is a left foot that has been mirrored, right? So the block has the ability to automatically detect whether an image was mirrored, both for radiographs and photographs. And that's it.